All right, welcome back. And now we're going to do another example. And this is instructional in that we're going to use matrix notation. And so this is an introduction to matrix notation. Okay, so we're going to consider this matrix A. So here's the matrix A, where A is equal to the matrix of all Aij. Now, the way you want to understand this is the notation for a matrix where this involves all of these elements. And so these ij elements, these subscripts, remember, the order matters because the I represents the row, the ith row that this element is located, and the J represents the jth column that this element is located. So this is a shorthand notation that we can use to write just the general, for a general matrix, right? So this here would be, represents A, right? So this is the notation that we would use. Now, so now to understand this, to help us understand this, let's look at an example, because here they say, okay, determine the value of each of the following elements. Remember, the subscripts here represents a particular element in the matrix. For example, this element here is in row 1, column 1. So this would be A11, right? So A11 is like this with the subscript 1, 1. This is not 11. This is 1, 1. So row 1, column 1. And that would be equal to -4. So this is A11, A12, 13, A14, A21, 22, 23, 24, A31, A32, A33, A34. Okay, that's how we do this. And so, with that in mind, if we want to know, hey, what's the value of the element A31, all we have to do is go third row, second column. Third row, second column, so this would be 8. And then here, this is second row, third column. See how the order matters? 3, 2 is not necessarily the same as 2, 3. Well, they're not as far as location. They're completely different locations or elements in the matrix. So second column, third row. Or excuse me, I'm sorry, misspoke. Second row, third column. So second row, third column is 0. So A23 is 0. And then first row, fourth column. So that's first row, fourth column, and that would be -pi. And that's it. That's how you determine the element of a matrix, or the element value.